In this video, I'm just going to outline the basic concepts of single point perspective. To do so, I would normally use a ruler, but I want you to realize that it's not measurements that are important in this case, it's just the straight line. So I'm using a straight edge triangle with no measurement markings and my mechanical pencil to keep my lines nice and crisp. My first concept is going to be the horizon or eye level. Those are both words for the same thing, where your eyes are in the picture, what your eye level is. In this case, I'm going to put a line through the center, and this is a normal view, and a line down towards the bottom. This is a worm's eye view, makes you look up at things. And then up at the top, this is a bird's eye view, it would make you look down at things. You only get one horizon, you have to pick. And to tell you the truth, the horizon line doesn't even have to be inside your picture plane. The picture plane is this white rectangle that we're looking at, and that's where we're going to be drawing. But right now I'm just showing you that there are different horizons that you can choose from. You define your horizon. The first thing you have to do in any linear perspective drawing is figure out what your eye level is, because that's the audience that you're playing to. Now I'm going to ignore the bird's eye and worm's eye views, and I'm just going to look at this central horizon line, and I'm going to put one dot on there. We call that the vanishing point. Sometimes we'll label it VP. You get one in a single point perspective. If we had more than one vanishing point, all the other vanishing points would end up on the horizon as well. While there are other reasons to have the horizon, the key reason we have in a single point perspective is to know where to put the vanishing point. You put it on the horizon line. So we're going to go back to the beginning of the 15th century, when an architect named Filippo Brunelleschi systematized his concept of linear perspective. I don't like to use the word invented because really linear perspective is based on the way that we see. It was already there. He just came up with a good system, and he used mirrors to prove it. I'm going to simplify it quite a bit here, and I'm going to base it on his very obvious observation that as something gets farther from you, it looks smaller in your eyes. So my hand looks smaller as it gets farther from the camera. He also pointed out that as things get smaller in the distance, they look smaller at a regular rate. So the bucket closest to me is large, and then the one twice as far away from me looks half the size, and 3 times as far looks 1/3 the size, and so on and so on. Well, in geometry, a regular rate can be described as a straight line. So all of these lines are going back to a place where the buckets get so small that I can't see them anymore. And that point where things get so small that we can't see them anymore, we call the vanishing point. Things get so small that they vanish. Point infinity. Now let's try some practical application. I have my straight edge and my pencil, and I'm going to pick a horizon line, probably near the center of the page, just to sort of show how this works. And the horizon line is just going to set my eye level. Then I'm going to pick a vanishing point on that horizon line. Towards the center seems to be sort of the easiest at the moment, so I'm not going to worry too much about where I'm going to pick it or what angle I'm going at. This is just a central view. So there's my vanishing point, and now I'm going to make 3 boxes just to show how this is done. And to do this, I'm going to use a straight edge. One box will be below the horizon, one will be above the horizon, and one will be crossing the horizon. And these will be to the right of the vanishing point, just so that I can show you what things look like off to the side. We'll do some in front of and above and below the vanishing point in just a little while. These boxes just start out with the facing end facing us squarely. So you can see that I've overdrawn some of the edges, and I'm going to erase those bits. In linear perspective, it's just as important what you draw as what you erase, because we often overdraw things a little bit so that everything crosses just right. Now I'm going to use that vanishing point, and I'm going to connect the corners of my boxes. I'm going to do 3 corners, not the 4th one farthest from it, because that would actually be drawing through the object, and I'm not going to draw so much through as just sort of overdraw the corners. Now you can see this looks sort of like a big long rail as I draw this last line here. It's going to look like a big long rail going back to the vanishing point, so it gets so far away eventually that we can't see it anymore. I'm going to do the same thing with this box that crosses the horizon, and then I'm going to do the same thing with the one below the horizon. The one above the horizon looks like it's hanging in the air or from the ceiling or floating there just like bricks don't. The one below the horizon looks like it's sitting on the ground, and the one crossing the horizon might be sitting on the ground in the distance. We're not sure exactly what. It's the visual cues and the positioning of everything that's going to give us quite a bit of information. Now I'm going to make these long rails into boxes, and to do so I'm going to look at the front shape, the squares and rectangles on the front, and I'm going to look at the angles, and I'm going to move those angles back to the back end of these shapes. How far back? I'm just going to eyeball it. I do that quite a bit, and each of these boxes is about the same size, a little bit larger if the end was larger. Notice all of these lines going back to the vanishing point outside the object that I've drawn are being erased, and the back lines all match the front lines on the object. So the front square, horizontal and vertical, the back, horizontal and vertical. Basically only have three choices and directions in these lines. One is horizontal, another is vertical, and then the other lines are all diagonal, but they go back towards the vanishing point. So depending on where I start my line on those, they'll have a different angle, all based on that vanishing point. So these objects look like they go back in space. I'm showing you little arrows the direction that they go. Now I'm going to draw three boxes, one in front of the vanishing point, one below the vanishing point, and one above the vanishing point. Now the boxes on the right, notice that I see the inside edge facing the vanishing point. If it's above the horizon, I see underneath it, and if it's below the horizon, I see on top of it. But if it crosses the horizon, I neither see on top nor underneath. I just see the side. Now, I'm going to use that same vanishing point, so I left it there inside that box, and I'm going to draw lines going towards that vanishing point from the box above, and then I'm going to cut it off using the same angle as the shape on the front, and now I have, very simply, a box once again floating in the air. Another one sitting on the ground down here uses the same lines. Notice I do not see to the right or the left of this object, I only see the top of it. And then the one that is in front of the vanishing point, I have no lines to draw back. All I see is the end that's facing me. This is a simple single point perspective of 6 boxes. Now I'm going to show you that when I rotate this, look, those boxes that were on the right are now on the left. It doesn't matter what angle I rotate this at, with a single vanishing point, it always works when you have your eye level in the center. So the horizon itself can rotate in this respect. This is a simplification of single point linear perspective for artists. And when we reduce everything to boxes, you can still draw many, many things in this world. So here's an example of a single point perspective using boxes of different shapes and sizes stacked on top of each other, put in front of each other, behind each other, and you can see that the illusion is created of three-dimensional space.